So now we have Melissa Perry presenting the con side. And after she presents, Gary, I'd like both of you to sit up here for quick rebuttals and discussion.
Thanks very much. Gary. I took this on with great enthusiasm because it was an opportunity for a toxicologist and epidemiologist to take a point of controversy and to really hash it out. At the same time, I couldn't approach it without returning to some basics. It really helped me understand the context of causality. And I think it is safe to say that from time immemorial, scientists and philosophers have been trying to come to terms with causality. It's as though it is our natural need and desire to understand how things are caused and what the epistemology is of the things that we observe. And so beginning with some of the greatest philosophers, Aristotle had the same approaches to the same questions about material, formal, efficient, and final cause. He asked how, in fact, we could see what the final cause was and how could we explain it. That was in 300 BC. Moving forward in history to the 17th century, Kant and Hume had very strong debates as to what really constitutes causality. And Hume said, actually, you really can never explain causality. It's based on our own experience. He was quoted in saying that, for we can never in experience perceive that one event causes another, but only that the two are always conjoined. He also was very comfortable as a sentimentalist, that he felt as though the personal individual experience was a way of explaining our own experience rather than using inductive reasoning or belief in causality. Whereas Kant really debated Hume's points about the gazing populace receive greedily without examination whatever soothes superstition and promotes wonder. That is to say that it is the individual experience that matters. And Kant would argue that, in fact, events can be predicted. Now, fast forward to the early 1900s, and you have a theorist, philosopher such as Popper. Popper did not necessarily believe in proving causation. He was very aggressive in refuting theory and disproving theory and hypotheses. He believed in the critical rationalism or falsificationism. And he really is the person we can attribute to the notion of rejecting the null or attempting to prove the alternative hypothesis. With these theories of causality, we've seen a number of different concepts that we've been teasing out in different areas of scientific inquiry, including inductive and deductive reasoning. Much of the debates among Hume and Kant got into the details of inductive and deductive reasoning, and philosophers and scientists have been debating these concepts ever since. We heard yesterday about the use of the counterfactual as another way of verifying an event is preceded by a cause. That direct manipulation and experimentation is another way to explain how an outcome is affected, and that these theories of mechanistic or pathway understanding, or even parallel or analogy analysis, as well as confounding, are other ways of explaining causality. What's striking is that we have a series of explanations from Aristotle to Popper to even Sewell Wright. I wanted to mention him as really the person attributed to designing the directed acyclic graphs. Wright was very interested in showing causation as well. He was a geneticist, and he wanted to recognize that you needed to identify several different factors at the same time in order to fully characterize and even quantify whether or not they were related. So back to the way in which these resulting theories or streams have impacted our own thinking in epidemiology. Let's go and dive into the relationship between methylmercury and myocardial infarction. As an epidemiologist, and as was discussed yesterday, I think very deeply about Bradford Hill criteria. And as you lay out those 9 criteria, you recognize the parallels with several of these prior themes. Now, Hill was never identified as being directly influenced by any one philosopher, so the philosophical underpinnings of Bradford Hill have not been traced or identified. He never attributed his thinking to prior philosophers, but you can't help but recognize parallels and overlaps. So within this context, we have the notion of, as Gary Ginsberg just laid out, methylmercury, in fact, directly causing myocardial infarction. This is our theory as we propose it. But very quickly, you start to recognize that there are other sources, and Kim Buckelheide raised this issue of black box here. In many ways, this represents many other themes that we see in epidemiology, including confounding, bias, third variable, other competing events that would directly influence whether or not there's actually a direct relationship. So this is our problem. This is our perennial problem. And interestingly enough, as epidemiology advances, this box gets bigger and bigger. And so on the one hand, you might be able to explain the box as including things such as confounding, maybe even effect modification, genetic predisposition. Now we're moving into epigenetic changes, microbiome responses, nutritional, lifestyle, stress, psychosocial. So in fact, as Kim Buckelheide mentioned yesterday, our potential for complexity in the face of the lack of knowledge gets bigger here. And so for us to very simply say, we believe that methylmercury causes myocardial infarction, immediately falls prey to healthy skepticism as to the other pathways or the other directions in which this relationship can progress. So let's use Bradford Hill from an epidemiologic perspective and also trace or connect to these previous philosophical underpinnings to see how enduring these concepts have been, and reminding us that we actually haven't solved these. They are the same framework through which we ask the same questions again and again. So philosophical underpinnings includes plausibility. These are the same things that folks such as Aristotle and Kant and even Hume talked about. What we're talking about now in the context of environmental health decision-making are things such as pathways, adverse outcomes, mechanisms. And so do we have biological plausibility, as Gary laid out? Methylmercury causes myocardial infarction through an oxidative stress pathway. We could accept that. That sounds plausible, as Bradford Hill would lay out. How about temporality? It's another enduring theme that Aristotle observed and grappled with, as did Kant and Hume. Is the outcome preceded by the effect? And so within the epi studies, we have 3 prospective studies. One was positive, one was negative, and one was inverse. From an epidemiologic analysis, you would say, well, these are 3 prospective. Only one's really finding a very positive association. One's actually finding a negative, and then one's finding an inverse relationship. That's pretty mixed evidence to suggest that we have compelling evidence for causality. How about experiment, also known as the randomized controlled trial? We don't have any studies in which we've induced myocardial infarction through dosing of methylmercury. Or how about, almost in the counterfactual design, how about a decrease in myocardial infarction by removing the methylmercury from the environment? We don't have any experimental evidence to suggest that you could achieve that kind of impact. So the empiricists, and I think of folks including Popper and other standards for truly evaluating whether or not there's association. The strength of association, also known as a statistical test, we saw one guide being positive studies with odds ratios of 2 or less. And by and large, the prospective studies that exist currently are not finding an odds ratio of much, just around 2 or just below 2. So the actual size and the strength of the association is exactly powerful or impressive. And how about biological gradient, or also known as dose response? Both of the positive studies show dose response. The health professionals follow-up study showed no association, and that was the largest cohort study to date, with an impressive number of 51,000 men and 121,000 women. And then the NSHDS Swedish study found an inverse relationship, also increased methylmercury decreases in the risk for myocardial infarction. So do we truly have biological gradient in the context of epidemiologic studies? I would say that that's speculative. Now, I mentioned the philosophers, how they have grappled with some key definitions of causality found in Bradford Hill. I mentioned the empiricists. These are the other elements, the other nuances that regulatory scientists also want to know. These are the questions that weight of evidence analyses are always asking experts to evaluate. Reproducibility, that's also known as the weight of evidence. So we really, in epidemiology, we have a limited number of studies to demonstrate that there's an association between methylmercury and myocardial infarction risk, and those findings are quite mixed. Specificity. This is where careers have been made and designed, and that is the ability to fully and accurately control for confounders. Can you see the exact association within a very finite and confined set of situations, and can you demonstrate that the association is there? And whereas each of these prospective studies have done a great job doing their best to control for confounding, the idea that with the health professional follow-up study that the relationship is just attributed to negative confounding is a bit of a stretch, because you have another Swedish study that's actually finding a protective effect for methylmercury. So I would say we are not there with respect to specificity. And then coherence, that is, do the tox and epi studies agree? We don't have compelling tox studies demonstrating a potential causal relationship between methylmercury and myocardial infarction, so findings have been inconclusive between animal and human. And then finally, and this is the one oftentimes in Bradford Hill that we struggle and apply less scrutiny to, and that is analogy. Methylmercury is to carotid artery as it is to the brain, or that methylmercury is to oxidative stress as lead, cadmium, and arsenic are to oxidative stress. That is largely theoretical than it is anything empirical or has been demonstrated through extensive analysis and empirical data. So I would argue that the status of epi data thus far leaves us at a place where we have to keep on evaluating what's in this question mark. And really, rather than coming to an immediate conclusion that this causes this, we have to go back again and again to ask what else is being missed here, and also what might be the relationships between the exposure, the accompanying beneficial protective effects of polyunsaturated fatty acids, and then risk for myocardial infarction. So I brought up Popper because, interestingly enough, in the discussions yesterday, we talked far less about theories and far less about hypotheses, and have gotten away from talking about the rejection of the null and the accepting the alternative. And in essence, the aggressive falsification of science is to put forward a theory and then to dispute it and refute it and replace it with yet another more compelling explanation that experimental observation makes a theory untenable, falsifies it, and a new theory is found that has greater explanatory power. It can account for the previously unexplained phenomenon, and as a result provides greater opportunity for its own falsification. And that is really at the heart of what we do in science. We continue to get it wrong, we fail, we improve, and we do it again. Now, what does that mean for regulatory decision making? I don't mean to imply that we keep on simply just studying the problem. What it really says is that we make decisions with the best evidence possible, and then we go on to improve that information, that evidence. This will always be a process. So where we are now is a place where these very limited unidimensional epidemiology studies are unsatisfying. The evidence is not compelling. You really wouldn't be in a position to make a regulatory decision or come up with a guideline about cost-benefit analysis based on the scant literature. And what it also says is that our methods have to get better and better in order to move forward with the best information possible. So I'll leave it at that.